Hello everyone, welcome to Circuit Analysis video lecture series. My name is Gebrie Teshome. I'm from Federal Technical and Vocational Training Institute, Department of Electrical Electronics. So please share, subscribe, like my video lecture so that it will be accessible for the others. So for today, we'll start chapter 1, which is as you can see here, the outlines, basic electric circuit. So under this, we have 4 subtopics: review of electrical parameters, elements of electric circuit, electric sources, and fundamental laws. Okay, so we'll cover this. So when it comes to the introduction to electric circuit, what does it mean electric circuit analysis means? Basically, this electric circuit analysis means that it's the study of the behavior of a circuit, such as how does the circuit respond to a given input, or how the interconnect elements in the circuit interact with each other. That means we have the circuit, we have the input, we have the output, so that how these parameters interact with the components connected in the circuit. So generally, when we are saying electric circuit analysis, it is the process of determining voltage across an element or current through the element of the circuit. Okay, of course, we'll come to what does it mean elements of the circuit. So when we consider electrical engineering, we are interested most of the time two very important points. That means communicating information and transferring energy. Okay, so basically for communication purpose, we need to have a communication signal, we need to have the sender side, we need to have the receiver side. So there should be a media that connects the input and the output side. That means the sender side as well as the receiver side. So this media is, we call it electric circuit, okay? And also there should be energy transfer from the source side to the energy consumption side or the load side. So between the source side and the energy consumption point or the load, there should be a media that connects the source and the load. So this media is basically the interconnection of electrical device, which is, we call it electric circuit. So this electric circuit is composed of electrical components or devices or elements that build up the required circuits. So an electric circuit is an interconnection of electrical elements, and the path through which an electrical current flow is called, basically, we call it electric circuit. So to build an electric circuit, elements in the circuit are represented by the electrical symbol. Okay, so basically, as you can see here, we have a simple circuit that consisting of a lamp and a battery. So for connecting the lamp and the battery, there is a connecting wire. So as you can see here, this is a physical device connection. This is a physical device connection, and this is the circuit that represents the components. So that, as you can see here, the lamp is represented by this symbol, the battery is represented by this symbol. This is the switch for controlling the flow of current. That means when you make it on, the current will flow through the battery so that the lamp will glow. And when the switch is off, definitely the current will be interrupted, so there will not be light which is obtained from the lamp. So this is how the electrical symbols represent. And like this, we have different electrical components. For example, we can consider the symbol for a resistor. Resistor is one component of electrical circuit, so that it can be represented by using this symbol, or it can be represented by this symbol, especially when the load is represented by using this symbol, can be represented. And also there is another component which is capacitor. So the symbol for the capacitor is represented by this symbol. And also there is very important component or elements of a circuit, which is inductor. So this element can be symbolized by using this symbol. And also we have a voltage source, a current source. Okay, so the voltage source can be represented by using this symbol with terminal. Okay, with this terminal, and the current source can be represented by this. Yes. So the arrow of the current source will be indicating towards the positive terminal of the equivalent voltage source. So this is how the elements can be represented by using their symbols. So in electric circuit, there are various elements or components that constitute an electric circuit or built-up electric circuit. So these components are source of electrical energy that delivers the required amount of power to the load, the switch for the controlling the flow of current in the circuit, load, which is responsible for consuming the electrical energy which is coming from the source, the electrical source. Interconnecting wire, there is interconnecting wire that is very important for connecting the source and the load. And also we have a protective device. This is a protective device. So for a normal operation of the system, basically there will be an interrupter current which is flowing through the electrical device. If the system is facing disturbance or interruption, so the protective device will act so that the components in the circuit will be safely kept. Okay, so that's some of the components of the electric circuit that constitute electric circuit. Okay, so when we come to subtopic electric circuit parameters, so the first one is charge. It is the most basic quantity of electric circuit. Of course, it is an electrical property of the atomic particles of which matter consists, especially if you remember from your elementary physics courses. So matter is made up of the fundamental building blocks of atoms, and each atom consists of subatomic particles such as the electrons. These electrons are negatively charged, negatively charged, and these protons are positively charged, okay, and this neutron is zero charge. This neutron has have zero charge, okay, or they are neutral. They are neutral. Okay. So the unique feature of electric charge is the fact that it is mobile. So if there is a motion of charge, definitely there will be current flowing through the circuit, and the unit of charge is coulomb. So in 1 coulomb of charge has 1 over 1.602 times 10 raised minus 90 electrons, because 1 electron has a charge of 1.602 times 10 raised minus 90. Okay, it has such amount of charge. So in 1 coulomb of charge, there will be such amount of or such number of electrons. Okay. So charge can neither be created nor destroyed, but transfer from one point to another. Okay, that means this is indicated as conservation of charge. Conservation of charge. Okay. So the algebraic sum of the electric charge in a system does not change. Therefore, we are interested with the motion of electric charge as it creates electric current in electrical circuit. That means as far as there is a motion of electric charge, definitely there will be electric current in the circuit. So when we come to the second parameter, this is electric current. Electric current, basically, it is the time rate of change of charge. This is the time rate of change of charge, or it is the net flow of electric charges. Yes. That means if there is net flow of electric charges in the circuit, basically there will be electric current flowing through the circuit. Mathematically, it is represented by using this expression. That means current is given by the time rate of charge, or the time derivative of charge, where current is measured in amperes, because as you can see here, 1 ampere means 1 coulomb per second. The unit of charge is coulomb and the unit of time is second, so 1 ampere means 1 coulomb per second. And one thing we need to consider here is the instrument which is used to measure electric current is ammeter. That means we can consider instrument, which is ammeter. So the ammeter is very important to measure the current flow through the circuit. You can consider, for example, you have a source, okay? So the ammeter should be connected in series with the load, okay? So this ammeter is responsible for measuring the current flowing through the load. So the ammeter is always connected in series, always connected in series, okay, in series, so that we can measure the current flowing through that device, okay. And one very important point why the ammeter is connected in series. So the ammeter is basically it has characterized by very small resistance, very small resistance, so that the voltage drop on the terminal of the ammeter will be 0 or approaches to 0. V ammeter, which is equals to 0, because it has a very small resistance. That means RA approaches to 0, okay. That's why it is connected in series. The charge transfer between time t0 to t is obtained by integrating both sides, as because we have said that I of t, which is dq of t by dt, so multiply both sides by dt, so you will have I of t dt, which is equals to dq t, okay. So take both sides integration, you will have the integral dq of t, which is equals to the integral t naught up to t I of t by dt. So q of t, which is equals to the integral t naught up to t I of t dt, okay. So we can, at any time t, we can determine the charge flowing through the element in the circuit, okay. So electrical current flows from a region of high charge or high concentration charge to a low or low concentration of charge, or from high potential to low potential. That means current will flow from high potential to a region of low potential, okay. Basically, we have two types of currents. That means the electron currents and the conventional currents. Okay, so the electron currents are flowing from the negative terminal to the positive terminal. As you can see here, this is the electron current. Okay? Electron current. Whereas the conventional current is flowing from the positive terminal, to the negative terminal. Okay, so this is conventional current. Okay. So most of the time in engineering circuit analysis, conventional current is used, and in other science and physics, so electron current will be used for circuit analysis. So conventional current assumes that current flows out of the positive terminal through the circuit and into the negative terminal. Okay, whereas the conventional current is flowing out of the negative terminal and entering into the positive terminal. Okay, their difference is direction. The magnitude is the same. So having this, we have two types of current. This is direct current and the AC current. So for the direct current, the current does not change with time, always flow in one direction, and it has a constant magnitude. That means to show graphically, you can consider this is time and this one is I of t. So you can consider this is I. Okay, as you can see, this is direct current. Direct current or DC current. So as you can see, when time goes to infinite, so basically the current magnitude will be constant, or it has a constant magnitude, and the current flows in one direction. Okay. When it comes to alternating current, the AC current does not flow in one direction. That means with time, the direction of the current will be changed, and it has no constant magnitude. That means the magnitude vary with time, and we have different forms of alternating currents, but most of the time we are going to use the sinusoidal waveform. Of course, we have a square wave, triangular wave, seesaw waveform, but most of the time in common electrical household devices used is the sinusoidal waveform. So you can consider this. This is I of t, and this is t. So you can see this one. So this is the peak value. This is maximum value, both in both directions, both in positive as well as in the negative direction. So you can see here. That means it starts from 0, so it comes to the maximum value. So it attains its maximum value, and it comes to reduce its magnitude, and comes to 0 again, and it goes to the negative peak value. After achieving its negative peak value, so it goes to the 0 value. So this is a periodic sinusoidal waveform. So it is alternating current. Similarly, of course, we can have a square wave, okay, square wave. So you can consider this periodic square wave. So as you can see with time, the current varies with a square waveform like this. Okay, so this is alternating current. So let's see examples. How many coulombs of charge are represented if the number of electrons are such amounts? You can do this by yourself. Let's consider this one. That means we have said that one electron is equals to a value of 1.602 times 10 raised minus 90 1 coulomb. Okay, or we have 1.602 times 10 raised minus 90 coulomb per electron, or charge per electron. So let's consider such amount of electrons, 6.482 times 10 raised 7, which is equals to how much amount of charge. Okay, let's say this is QC. So QC, which is equals to 6.482 times 10 raised 7 times 1.602 times 10 raised minus 90. Okay, this is electrons, this is coulomb per electron, so electron will be cancelled by electron. So you will have 1.602 times 6.482 times 10 raised 7 times minus 90, which is minus 12. Okay, so 1.602 times 10 raised 6.482 10 raised minus 12, which is pico. So picocoulomb. Okay, picocoulomb. So we can have this amount of value. So you can take the product. When you come to the value of charge which is flowing through the circuit or elements of the circuit is given by such expression. So you are asked to determine the current flow through an element if the charge flow is given by this amount. So for the first one, we have given I of t, which is equals to Q of t. Okay, so let's have Q of t, which is given by 3t squared plus 8, which is millicoulomb. So we are asked the current passed through the element I of t, which is equals to our. Okay. So now let's consider the definition. I of t, it's given by d by dt of q of t. So d by dt into 3t squared plus 8 millicoulomb. Okay, so d by dt of 3t squared plus d by dt of 8, okay, millicoulomb. So this is 60 plus this is 0 because it is a constant. Okay, so milliampere. So the expression for the current passed through the element is given by this expression. Okay. The second one, we have given that Q of t, which is 3t squared plus Q of t, which is 3t squared plus 6 e raised to minus 0.5, which is the magnitude, which nanocoulomb. Okay, with the same procedure or with the same approach, I of t, which is given by d by dt of q of t, okay, which is equals to d by dt of 3t squared plus 6 e raised to minus 0.5 t. So we have d by dt of 3t squared plus d by dt of 6 e raised to minus 0.5 t. Okay, 5t. So we have 6t plus 6 e raised to minus 0.5 t times d by dt of 0.5 t. Okay, so 6t plus 6 times minus 0.5 e raised to minus 0.5 t. Okay, so you'll have 6t minus 3 e raised to minus 0.5 t nanoampere. Okay, nanoampere. So this is the expression for the current flow through the circuit. The third one, this one is the third one, which is of t, which is given by 10 cos 100 t picofarad. Sorry. So as usual, you have I of t, which is equals to d by dt of q of t. Okay. So d by dt of 10 times cos of 120 pi t picocoulomb. Okay, so we have minus 10 sine of 120 pi t d by dt of 120 pi t. Okay, so you'll have minus 10 times 120 pi sine of 120 pi t. Okay, pi t. So pi t. So pico ampere. Okay. So that's how we can determine the expression for the current pass through the element if the charge passing through the element is given. So we have seen, to summarize the points, we have seen basically the basic definition of circuit analysis and the electrical parameters, current and charge we have seen up to this point. Thank you very much. Please share, subscribe, like my video lecture so that it will be accessible for the others. Thank you.